Hey, also in this video, I was going to show you something called scenario analysis, which is one of the things that is mentioned in the second part of those project guidelines. So there's three things, remember, that you have to do to improve your project from the project to draft to the final project, which included fixing the errors I talked about in the draft, doing stuff with regression statistics, so like interpreting p-values on slopes and stuff like that, and adding at least one extra independent variable so that you're doing a multiple regression. And then there were, I think, 5 other possible things you can do. There's a wide variety of stuff you can do to expand. Those are really suggestions. Usually people do those suggestions. One of those is called scenario analysis. So in the last video we did forecasting. Scenario analysis is pretty similar to forecasting, but in forecasting, we're like, I'm trying to make the best guess of what I think is definitely going to happen. So we did those Ogden home prices and said, what do we really believe Ogden home prices will be 2, 3, 4 months from now? Scenario analysis is a little bit different in the context of we pick different scenarios. And so today I'm going to do this California, Massachusetts, Texas oil price affecting gas price that we did a few weeks ago. So we're going to do a scenario analysis. What will happen to gas prices in the high oil price scenario, in the medium oil price scenario, and in the low oil price scenario? So that's a little bit different. So instead of saying like, I think this is definitely going to happen, we're saying, well, what's going to happen if oil prices are high? What's going to happen if oil prices are low, and what's going to happen if oil prices are kind of average. So the way I'm going to start that is by just giving myself some summary statistics about oil prices, and that will help me decide what my different cases can be. So let's go ahead and go down here and say maybe min oil price, mean oil price, and high oil price. And so what I'm going to do for the min is just to do equals min, and then I can go click on the crude oil price data, right? And that's going to return the minimum oil price in my data set. So that might be a good choice for our low oil price scenario. I'm going to go here and I'm going to say equals average oil price. What's a good oil price to use for the mean or average scenario? Well, the mean or average oil price. This is actually pretty high considering current prices, but maybe we're thinking about the long run, and if we expect oil prices to converge to their mean, maybe that's a good one to use. Equals max. So of course, if we're using min for our low oil price scenario, it would make sense. So there's our 3. Now we can use those in our 3 scenarios for what's going to happen to gasoline prices if we have low oil prices, medium oil prices, or high oil prices. You might use the median instead of mean, and that's, you can totally decide. I'm okay with you choosing, if you decide to do scenario analysis, do it however you want. Just to make sure to have an explanation for why you picked that case or why it's interesting. Okay? So now we actually want to think about a few different outcomes, because remember in this regression, I started, by the way, with the same spreadsheet that I've already provided for you when I did this other more categorical variables in Excel video. So you already have access to this and we can just add to it. We've already run that regression. So now we're going to predict gasoline prices in each of our different scenarios. So remember that really to do this, we'll go do our scenario analysis over here. We're going to have different states. So let's have Texas, California, and Massachusetts. Make all those bold. And then we'll have our low oil price, medium oil price, and high oil price. Make those bold. And now these right here, I'm going to go up here, and this is a nice thing you can do in Excel. I'm not sure I've done it in a video before. If we do, I think it's just at home actually, or maybe data. Let's see. Right here, there's a button called Merge and Center. I can merge all those cells together. And then I'm going to write in there scenarios. Because my 3 different scenarios are defined by different oil prices, right? So I'm going to have a low oil price scenario, a medium oil price scenario, and a high oil price scenario. So let's go ahead, and for our low oil price scenario in Texas, I'm going to do equals. There's going to be an intercept. So we're just plugging in our low oil price into our Texas price scenario. So equals the intercept plus the crude oil price slope times the min crude oil price right here, right? So that's going to be my estimated gasoline price in Texas for my low oil price scenario. So now we could do the same thing for medium oil price, intercept plus slope times the mean oil price. So that's obvious, a little bit higher, then equals intercept plus high oil price, or I'll do slope times high oil price. And now for the state of Texas, we have 3 different scenarios. Well, if oil prices are low, we expect gasoline prices to be about $1.24. If oil prices are medium, we'd expect gas prices to be about $2.40. And if oil prices are high, we'd expect gas prices to be about $4.40. So that obviously could be valuable information for a company. Maybe a delivery company that drives around a lot of trucks has their costs are going to be very tied to gas prices. And then so you could present different scenarios to a manager at such a company. Well, these are going to be your different gasoline prices in your different scenarios. Multiply those by the average gas use over a week or a month, and then you have costs from gasoline in these different scenarios at that company or something. So now let's go ahead and do this for California. Remember, this is going to be a little bit different because we have a different intercept for California, but because we included this dummy variable for California in our regression. So now we have to remember to deal with those for both California and Massachusetts. I've already gone down here and calculated the California intercept because remember when we do the algebra, we see that I have to add B0, B0, and B2 together to get my California intercept. So I've already done that down here from last time. Massachusetts intercept similarly, but we'll look at that in a second. So for California, low oil price is going to be equal to the California intercept plus the small oil price times the crude oil price slope. Medium equals California intercept plus slope times medium oil price. It doesn't matter what order I multiply those in because multiplication order doesn't matter, right? You'd have to be careful if we were doing division or subtraction or something like that, but in this case it's okay. Now this one's going to be equal to California intercept plus slope times high price. And so now we have our 3 oil price scenario gas price estimates associated with each scenario for the state of California. Notice those are all a little bit higher. Well, what happened? They were shifted up by about 57 cents. And in fact, I think if we did equals this minus this, oh, what number did we get? And if we just go over 3, in all cases, these California prices are all just shifted up by what they should be shifted up by. Because that shows we're just shifting up the California line. Whoa, I froze. Sorry about that. Relative to the Texas line. So it makes sense that we just get back that intercept if we look at the difference between California and Texas. Is this creepy? Maybe I should get rid of my frozen face. Yeah. Maybe we can try it again. Hello. Okay, now let's do it for Massachusetts, which again, this is going to be a slightly more complicated now, right? Because for Massachusetts, we allowed the intercept to change, but we also have a different slope for Massachusetts. So down here, to recall, I added my baseline intercept. I added to that the Massachusetts dummy variable coefficient because that's shifting up the line for Massachusetts. But then I also allowed there to be a different slope in Massachusetts by including this. And we saw that in the categorical variable algebra video too, how we can get a different slope for different values of dummy or categorical variables. Now I've already calculated that different slope, which just takes, we use the regular crude oil slope and then add this negative number or subtract 0.006 from it. So let's go for Massachusetts now. The low oil price scenario is going to equal the Massachusetts intercept plus the Massachusetts slope times the small oil price. This is going to equal the Massachusetts intercept plus the Massachusetts slope times the mean oil price. And this is going to equal the Massachusetts intercept plus the Massachusetts slope times the high oil price. And that's pretty interesting because now compare the Massachusetts prices to these other scenarios. Because the rate of change in gasoline prices for higher oil prices is smaller in Massachusetts, we actually get a lower gasoline price estimate for Massachusetts when the oil price is really high. Even though the starting point is higher by 60 cents higher, even more than California, as oil prices increase, the Massachusetts gasoline price increases at a slower rate because we have a smaller slope, 0.019, about 2 cents per dollar increase in oil price versus 2.5 cents per dollar increase. And that seems really small, but that's just the intercept. As we multiply that by these increasingly big numbers, it has a bigger and bigger effect. So in the low price scenario, Massachusetts is still expected to have a higher price than Texas. But by the time the oil price gets really high, because of that flatter line, we actually have a lower gas price in Massachusetts for those high prices. So let's take a look. Remember that when we compared, let's do this again, California to Texas, we just got that intercept back. But when we do that comparison equals Massachusetts minus Texas, the difference between Massachusetts and Texas gasoline prices, it's much higher in California for the low oil price scenario. But as oil prices get higher, the difference goes down in the middle case because now we're hitting that lower slope with a bigger oil price. And then right there, it's actually decreased. So for that high oil price scenario, we actually expect gasoline prices to be a little bit lower in Massachusetts than they are in Texas. All right? So that's how you do scenario analysis. I would just wanted to show you that kind of for purposes of, let's keep that there. So when I send you the spreadsheet, that's there. You wouldn't necessarily want to present that, but it's worth thinking about what's going on with these differences. But right here, you could make a nice looking table like this and put it into your project, and that'd be a really good thing to do. And this is like a scenario analysis because, again, instead of like forecasting exactly what we would think will happen next month, we're giving kind of a menu of different situations or different scenarios to present. And this happens all the time in business environments. What's going to happen to our company if oil prices are really high next year? What's going to happen to our company if oil prices are really low next year? What's going to happen to our company if oil prices are average next year? And that can obviously be useful information in a lot of different contexts. All right, so let me know if you have any questions, if you'd like to apply this to your project, and I'll see you guys later.